All right, let's finish catching up. Okay, so part 3, this was really just like there's a really specific part in the homework that's a little weird, and I just want to make sure you understand like what's happening with inverse. Inverse, as you can see in the top right, is a reflection over y equals x. So these two would be inverses of each other, and you're gonna have to pardon my drawing because I'm doing it with a mouse. That and that would be inverses of each other because they've reflected. What else did I do? I did like cube graph and, oh my goodness, this is going to be tough. Cube graph, like those are inverses of each other. But the biggest thing we're going to talk about is square root graph that looks like that, and the inverse would look like that, kind of. You can see how it's, I'm really sorry I'm drawing with a mouse. I did it so much better in class. The problem is this is the true inverse. Yay, phone calls. Okay, so the problem is when we do them, this is the true inverse of what's happening. The problem is it's really tough to get this graph. Usually when we do the inverse of a square root, we ended up getting, if this is square root of x, let's say plus, nope, because that sends us to the left, minus 4, then this would be x squared plus 4. However, we know x squared plus 4 is actually this graph. So we're going to actually have to say, look, because we don't have this part of the graph here, we cannot have this part of the graph here. So how do we talk about what's happening? How do we say, look, I need to make sure I don't have this? Well, it'll be pretty simple. We're going to say, look, right now, y has to be greater than or equal to 0. Like we are not going to get this side. So over here, because remember with inverse, x and y just switch, we're going to say x has to be greater than or equal to 0. So that would then take away that side of the graph and leave us with just from 0 on. So that's how we'll have to do it. It's a little weird, but it's the same thing with, let me do this. Code page. It's the same thing with like x squared, something like that. This would be the inverse. The problem is this is not a function. Our vertical line test says if I touch 2 spots at the same time, it's not a function. Whoops. So how do we do this? Well, when we go from x squared to the inverse, we would get square root of x, but this is why we do plus or minus. Because we don't have a plus or minus button in the calculator, really what's happening is we have the plus version of square root x, and we have the minus version of square root x at the same time. So we're going from like 1 graph to 2. So you gotta be careful, like the true inverse here would actually be, well, not a function, because again, vertical line test, it's really truly 2 functions happen at the same time. You just gotta be real careful. So consider the function, determine whether the inverse is a function, then find the inverse. Basically, and I went back here and I said, look, as long as you're not working with an even exponent or a even root, because this could totally say 4th root of x, and that could say x to the 4th. As long as that's not an even number, then you're good. Wait, sorry, I'm losing track because it's 7 o'clock. As long as it's not an even number, then you're good, which is what I said. If it is an even number, that's when it's like, okay, well, going from here to here, it's not a function because we can't have both plus and minus or whatever. But any odd exponent or odd root, both of these would be functions totally fine, because we talked about the one that kind of looked like the one that kind of looked like this, and the other graph looked like that. Like they're functions. So the cube and cube root stuff, those are fine. So I told them, look, let's find the inverse, then see if it's a function, which we did. We go back to video 1 if you need to know how to find the inverse. Find the inverse, see if it's a function. Well, we have a cube root and a cube, so we're going to be fine. It's, again, anytime you have x squared or x to the fourth or cube root, or sorry, square root, fourth root, sixth root, anytime where you have to have a plus or minus in front, that's when it gets a little iffy. So, for example, like this. This is where it gets a little weird. Consider the function, determine the inverse. Okay, so we found the inverse, and we get this right here. So we got this green graph starting off, and we're looking for this red graph, because when we draw it out, clearly that's the inverse. The problem is, let me get some of this stuff out of the way. Hold on. I'm sorry. Yeah, I can leave that there. I'll come back. The problem is, and let me draw it out. This right here, what we found down here, x squared over 4 plus 3, is this entire, orange is a terrible color to use. Blue will work. That's this graph, actually. And we talked earlier about how, look, we don't even need this side. But again, we're going to come down here and say, look, since we're trying to cut off this side, y is never going to be a negative, so x can never be a negative. We're going to kind of restrict our domain a little bit in order to get just this half. Now, obviously, and that's kind of what here, if I had an up-down shift, which we'll talk about on two slides. As long as I don't have an up-down shift, like this would move my graph down to here, which would then move this over here. Then I would say, well, now, if I'm here, then y is this whole line of what would be, y is never going to be less than 1. It's got to be greater than or equal to -1. So over here now, x, here's my x, we're going to have to start at -1 and go up. So it kind of makes sense. Next time I open this page, I can do that. But yeah, that's why we talked about restricting the domain. And here's the answer for it. And again, we're making sure that we don't get this whole graph, because x squared, that's an x squared graph. So that's why we have to come down here and say, oh, by the way, we only want from x equals 0 on up, because here y is going to be greater than 0. So there's the solution to that. So here's another one. And again, as long as we don't have an up, down, left, right shift here, then zeros are our restriction line, because we didn't take this and move it up. Oh man, I got the whole thing. Sorry, something like that. This didn't move up or down, so that's not going to have to move left or right. So we can say, look, we still need x is greater than or equal to 0. This one here, let me do this. No. Negative x squared, I talked about, look, negative x squared, just this right here is this graph. But when they say, look, I only want the negative numbers, well, that's where that goes. Because that way, when we find the inverse here, well, clearly I can't plug in a positive number here. So that's why it can't happen there. So we got to make sure we say, look, early on we had to say, look, x is not going to be a negative number ever. And we did the same thing here, where we know, look, we're going to have to restrict our domain, since y will always be bigger than or equal to 0. Down here, x will have to be bigger. And like I wrote that without even doing all this. I said, look, I'm going to have some sort of restriction here that I know I'm going to need to account for. So this one was a little weird, I know, but hopefully you get a better understanding of like what is actually happening with inverses. And I will say 22 is kind of an older concept. I threw it in there because somehow I skipped it. But 35 through 46, it's just more finding the inverse. So